Hi guys, how we doing again? Today we're going to start our new lesson, and that's going to be lesson 3.2. And it's finding GCF and LCM. All right, some of you guys might remember some of this from last year. I know that I had mentioned this last year when we were dealing with fractions and finding common denominators. I'm not sure if your other teachers have done that or not, but regardless, we're going to treat it as if this is new to everybody. Start things off, we have some vocab words we're going to go ahead and start with. First one is, we're going to skip down a line here, put a bullet, is prime number. So let's go and write prime number. And if you don't know, a prime number is a number that's only divisible by 1 and itself. An example of that would be 2, 3, 5, 7, and so on. Each one of those could only be divided by 1 in itself. The next number, or excuse me, the next vocab word we're going to look at is composite number. And a composite number is pretty much the opposite of a prime number. Composite number has more than 2 factors. So examples of that would be 4, 6, 8, 10, so on. They don't have to be even numbers. For example, 15 is a composite number. 21 is a composite number because it is more than just 1 times a number. So, for example, 21, it's not just 1 times 21, 21. It's also 3 times 7 would give you 21. Or 15 would be 3 times 5 would give you 15. And also 1 times 15. So that's how composite numbers are different than prime numbers. Composite numbers have more than 2 factors. Prime numbers only have 1 in themselves. The next thing we're going to get into, which this is going to be new to you, this is a term called prime factorization. So prime factorization is something that I'm sure your parents did when they were younger. They had things called factor trees, because when you get done doing this, it starts to kind of look like a tree. Let's go ahead and do an example of this. So prime factorization is taking a number and breaking it down into just its basic prime numbers. So we'll use 48 as an example. So I'm going to start with the smallest prime number that would go into 48, and that is 2. So 2 times what gives you 48, and that is 24. Now I can't break down 2 anymore, but I can break down 24. So again, the next smallest prime number that goes into 24 is also going to be 2. 2 times what gives you 24? That's 12. Can't break down 2 anymore, so I'm going to continue, and I can break down 12. And this one, I can break down with 2 times 6. And lastly, I can't break down 2 anymore, but I can break down 6. So in this case, it would be 2 times 3. So this would be broken down into all prime numbers. These are all factors that, when multiplied together, would give you 48. So one way to look at that is I could write it this way. I could write, let's see, there's 1, 2, 3, 4 2's there. So I could write 2 times 2 times 2 times 2, and then I have 1, 3 times 3. Or since we just worked with exponents, I could write 2 to the, let's see how many 2's are there? 1, 2, 3, 4. 2 to the 4th times 3. And if I were to solve either one of these, I would get 48. So that's just an example of prime factorization. This is going to be handy when we get into actually finding GCF and LCM, is looking for those prime numbers, being able to factor numbers down to their basic prime numbers. So speaking of GCF, let's go ahead and start learning about that. Let's get a new marker here. All right, so let's skip down here. And we have the GCF, which is known as the greatest common factor. So let's write that down. Greatest common factor, or GCF. It's a mouthful if you don't just write the abbreviation. So break this down a little bit. So greatest, if I just think of another word, that'd be like the most. Common is something that occurs frequently, and a factor we know has to do with multiplication. Two numbers that multiply together to equal a product. So I'm going to show you a couple different ways to be able to do this. So for the greatest common factor, the first way I'm going to show you is kind of the most common way. So if I have two numbers, if I have 12 and 42, and I want to find out what's the greatest common factor. So which factor is the largest that goes into both of these? And the way that I was taught how to do it, and I'm sure your parents were taught how to do it, is this way. We'll start with 12, and we think to ourselves in our head, does 2 times anything equal 12? So yes, it does. Then I go to, does 3 times something equal 12? I think in my head, yes, it does. Does 4 times something equal 12? Yes. Does 5 times something equal 12? No. Does 6 times something equal 12? Yes. And here's the thing, when you are at the halfway point, so 6 is halfway to 12, so that means there's not going to be any more factors that would go in there except for 12. So the original number was always going to be the last factor. You might be noticing here we didn't put 1. We never put 1 in here for anything, just because 1 goes into every single number, and it would never be the greatest. All right, next we go to 42. Does 2 times something equal 42? And yes, it does. And part of the reason why we know that is because this is an even number. 2 goes into all even numbers. All right, so now we think, does 3 times something go into 42? And if you're not 100% sure, you can do that 3's trick, which tells you we add these two numbers together. 4 plus 2 is 6. Does 3 go into 6? Yep, so that means 3 would be a factor. See, does 4 times something go into 42? I know 4 times 10 is 40. 4 times 11 is 44, so nope. Does 5 times something give you 42? Nope. Does 6 times something give you 42? The answer is yes. Does 7 times something give you 42? Yes. Does 8 times something give you 42? No. 9? Nope. 10? Nope. 11? Nope. And 12? Nope. And I'm going to stop at 12. The reason why I don't have to go any further is because 12 is the largest factor here. I don't need to keep going up to higher factors or larger factors here, because this one is the largest. So now I want to look at these and see, is there any number that they have in common? And if so, I want to find the largest one they have in common. So let's start here at the beginning and say, okay, do they both have 2s? Yep, so that could be it, but let's keep looking. 3s, yep, they both have 3s, so let's keep looking. Do they both have 4s? No. Do they both have 6s? Yes. They both have 6s. And that's the largest. I could go to 12, but I know there's no 12 here. So 6 is going to be the GCF. And that is one way to be able to find the GCF of 2 numbers. All right, moving on. If that's GCF, the next thing we're going to look at is the LCM, or the least common multiple. So let's skip down here, put a bullet, and I'll write down least common multiple, or LCM. And if we kind of break this down a little bit, we know least, that'd be smallest. Common, again, is something that occurs frequently. And multiple, if you have multiples of things, it means more than one. So let's go ahead and I'll show you how to find the LCM of 2 numbers. So let's use 6 and 8 for this example. So we want to find the multiples of these numbers. So I'm going to start by putting a little colon here on each one. And we're going to do multiples of 6. The way I like to do this is I like to take it out 5 times. So we'll start with 6 first. See, 6 times 1 is 6, comma. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. And 6 times 5 is 30. So I'll stop there, and I'll go down to my 8. Now the good thing about this is, once I find my match, I can stop. I don't have to keep going. So I'll do the multiples of 8. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. Now right away I know that I have found a match. This is the very first one, so I don't have to go any further. So 24 is going to be my LCM. So here's a question. What happens if you don't find a match? What if you went out 5 times on the first one, and then you went out 5 times on the second one, you still don't have a match? Well, then you need to start back at the top one and go out a few more, and do the same thing for the bottom one and go out. Usually you'll find it within the first 5 or 6 numbers, but sometimes it happens where you have to keep going. So that is one strategy to be able to find the GCF and the LCM. Now there's another way that I'm going to show you. It's kind of nice because what it does is it gives you the GCF and the LCM all in kind of one shot. So I'm going to turn the page. And this is also going to help lead into something else that we're going to be discussing here pretty soon. So if I have 2 numbers, we'll say 42 and 66. And I want to find the GCF and the LCM of these. We can do what's called the L method. And the reason they call it the L method is because you end up making L's. So what we want to do first is we want to think, what number goes into both of these 2 numbers? And usually it's easier to start with the smaller numbers because it just makes life a little bit easier. And can you do bigger ones? Yes, but it's just a little bit easier to start with the bigger ones, or excuse me, with the smaller numbers. So I'm going to go ahead and put an L underneath both numbers. And I'm thinking to myself, okay, what number goes into both these? And right away I think of 2. So 2 times what gives me 42? The answer is 21. 2 times what gives me 66? That is 33. And if you struggle with the multiplication part, maybe you can think about division. 42 divided by 2 is 21. 66 divided by 2 is 33. All right, so now neither of these are prime numbers. These are both composite numbers. So I know another number goes into both these. So I'm going to go and make an L underneath these. What number goes into 21 and 33? The answer is 3. So 3 times what gives me 21? That's 7. And 3 times what gives me 33? That's 11. Now these are both prime numbers. I can't multiply anything to get 7 besides 1 and 7, and same thing with 11. I can't multiply anything else to get 11 besides 1 and 11. So now, to find the GCF, I'm going to simply multiply these 2 numbers here. This gives me my GCF here. 2 times 3 is 6, and that's my GCF. If I want to find the LCM, so again, the least common multiple, I would have to multiply 2 times 3 times 7 times 11. You can see I'm going to finish my L here. And the L kind of stands for LCM. We'd multiply all these together. So I'll go ahead and write that down. It is 2 times 3 times 7 times 11. And I can kind of break this down a little bit. 2 times 3 is 6. 7 times 11 is 77. So now I just have 77 times 6, which is, again, you do this off to the side, but it's going to give you 462. So that's the least common multiple between 42 and 66. That means that I would have to multiply these out multiple times, and when I got to 462, that's when they would both intersect. All right, so you might be wondering, okay, well, why are we learning how to do it, GCF and LCM? Well, a lot of that goes into what we're going to be learning in the next couple lessons, and part of that is distributor property. Distributor property is when you are able to use an equation and write an equation and use factors that are on the outside of parentheses to be able to distribute that through the parentheses to be able to solve for a number. So, for example, if I have 42 and 66, and I wanted to add those two together, I know we could just sit there and say, okay, I can add 42 plus 66, and I can get my answer. Well, you're right, you can. But because we're in 6th grade, and this is helping to build up to our future lessons, we're going to break these numbers down and be able to show what it looks like if I do it using a distributor property. So what I'm going to do first for the distributor property, so I'm going to go ahead and write distributor property. Hopefully I spelled it right. This is going to be the method that we would use to be able to add these two together if we're using a distributor property. So what we'll start with is, we always start with the GCF. And our GCF, we said, was 6. So that is going to go on the outside of our parentheses. I'll draw a little arrow here for you, GCF, and I'll label it. Then on the inside, what we're going to do is we're going to take our final 2 prime numbers. So our final 2 prime numbers are 7 and 11. And right in between there, we're going to put a plus sign. We'll close the parentheses. So if I were to actually distribute this through, I would multiply 6 times 7, and I'd get 42. And then I could multiply 6 times 11, and I would get 66. Or the other way we can do it is I can add these two numbers together. So what is 7 plus 11? That is 18. And then I'll keep my 6 on the outside. And now I can go ahead and multiply 18 times 6. So again, I would do that on the side, but 18 times 6 would give me 108. So if I were to add together 42 plus 66, that would also give me 108. So again, I know you might be thinking, oh, this is a little confusing. I don't know why we're doing it this way if we just want to add these. It's because we're building up to be able to use distributed property in future lessons. The biggest thing though, guys, is find a way that is comfortable for you to be able to find the GCF and LCM. If you'd like to do the L method and do it this way, or if you'd like to do the GCF separate and the LCM separate, you can do it either way. But here's the biggest thing, guys and girls, is you need to try. You have to start somewhere. So when you start doing the greatest common factors, start at the beginning. Just start and think to yourself, does 2 times something give me 12? Does 3 times something give me 12? And so on. And then when you do that LCM, for least common multiple, you're going to actually you have to go through the steps and do your multiples of 6, your multiples of 8, or whatever your numbers are. So when we talk tomorrow, then we will, actually it's not tomorrow, I'll talk to you guys tomorrow about this lesson. When I meet up with you the next day, we'll come back and we'll take a look at this and we'll see where people are struggling at. But again, there's a lot of questions on your homework that have to do with this distributed property where you're going to be breaking these down. There's a lot of questions on there for GCF and LCM. Again, it's not that bad if you follow the steps. Please take advantage of doing your homework and using the question help. It's that blue button that's in the top right-hand corner. There's lots of question help available for you in those. You can watch videos or you can click on the button that says, help me with this problem. It is very, very useful. So, all right, hopefully I didn't overwhelm you guys with all the different vocab words and then the GCF and LCM, and then moving right into the distributed property. But again, if you have questions, please send me a message on Google Classroom, or you can go ahead and send me a private message, or just hit me up on our class time. So hope you guys have a great day. Talk to you later.